Consider the curve y equal to 2x power 3 plus 3x squared minus 12x plus 7. Find the stationary points of the curve and determine the nature. Sketch the curve, labeling the stationary points. Part 3. Hints or otherwise, find the values of x for which dy dx is positive. To find the stationary points, so that's when y dash is equal to 0. So therefore, given that y is equal to this, so first of all, we differentiate this first. So y dash is equal to, the 3 come down, so that means 2 times 3 is 6, so less 1, so square, plus the 2 bring down, so 3 times 2 is 6, so x less 1 is x power 1. So nothing up here is mean 1, 1 bring down, 1 times 12 is 12, so minus 12, x power 0 is 1, so it's 12. So differentiate 7 is 0. So this is it. So y dash is equal to 6x squared plus 6x minus 12. So when y dash is 0, this means that 6x squared plus 6x minus 12 is equal to 0. To solve this, first of all, I divide everything by 6 first. And to make it simpler, so this cancel out. So like with x squared plus x, this divide that give me 2. So that means x squared plus 6x minus 2 is equal to 0. Now to factorize this, of course, because it's a negative, so it should be 1 plus 1 minus. Then what time what give me 2? The difference is 1. Nothing in front, if x is 1. So this means 2 times 1. So the difference is 1. But because it's positive x, so we have to make a big number on this side. So 2 and 1 here. So that's the answer. So therefore, x plus 2, x minus 1 is equal to 0. So this means that x plus 2 equal to 0 or x minus 1 is equal to 0. So therefore, x is equal to negative 2 or x equal to 1. So that's it. Now we need to find the y values when x equal negative 2. So to find the y value, all we need to do is substitute into this function here. So this means that y is equal to 2, open bracket, minus 2 power 3, and 3, open bracket, minus 2 square, and so on. And to put that in a calculator, which give me 27. This means that minus 2, 27 is a stationary point. Stationary point means it can be maximum, can be minimum, can be point inflections. When x is equal to 1, again, we just substitute the x value into the function here and to find the value of y. So substitute in, and which give me 0. So this means that 1, 0 is a stationary point. Then now we have stationary point for this and 1, 0 as well. Now to find out whether the maximum minimum, of course, we have to test it by finding the second derivative. So we know that y dash is this. Now to differentiate, so y double dash is equal to the 2, bring it down, so 2 times 6 is 12. So 2 times 6 is 12, 12x, and then plus the 1 here, bring it down, so 1 times 6 is 6. So less 1 become x power 0 is 1. Then we'll just leave it. And then differentiate 12 is 0. So this means that y double dash is this. Now, at minus 227, to find out whether maximum or not, so we put that minus 2 into the second derivative, so which is 12 times minus 2 plus 6, which give me negative 18, which is less than 0. Now, because the y double dash less than 0, this means the graph is upside down. So therefore, it is maximum turning point. Okay. At point 1, 0, so y double dash is this, and we substitute in the second derivative functions, of course, and which is equal to 18. That is greater than 0. So your graph is concave upward. So therefore, it is a minimum turning point. To sketch the curve, okay, first of all, we know that the maximum turning point is minus 227 and minimum turning point is 10. So to sketch this, first of all, minus 227 roughly here. And then we don't forget, we can easily find the y-intercept when x is 0, so y-intercept is 7. So please make note on that as well. So minus 227, we have that already. 10 roughly here. And then we'll just sketch it. So let me just sketch this first and join it together, go all the way down. And then aim toward 1 at the point. Sorry, I missed it. But when you've done that, of course, I can just do it again. So just, there you go. So this is how you do the sketch for y equal to x power 3 plus 3x squared minus 12x plus 7. Of course, you have to label it properly. So this is minus 227 and this is 7. This is 10 if you like. And that's how you graph y equal 2x power 3 plus 3x squared minus 12x plus 27. Part 3. Hints or otherwise, find the values of x for which the gradient is positive. So the gradient positive is this onward, because if you draw a tangent, is the line going this way, so therefore it's positive. Same as this one is positive here. And this one here is negative, so we ignore that. That's not what we want. So therefore, this one here is from this onwards, so that's minus 2. So therefore, x is less than negative 2. Or this one here as well. So therefore, x is greater than 1. Consider the curve y equal to 4x power 3 minus x power 4. Find the stationary points and determine the nature. Sketch the graph of the function, clearly showing the stationary points and the x and y intercepts. Please pause the video, try to do it yourself, see if you can. To find the stationary points, so we know that when y dash is 0. So first of all, y is this. So y dash is equal to 4 times 3 is 12. So 12x squared minus the 4 bring down, so 4x plus 3. Then we make y dash is 0. So this means that 12x squared minus 4x power 3 is equal to 0. So the common factor of this is 4x squared. So 4x squared, I take it out. So 12 divided by 4 is 3. X squared is gone. Minus x is equal to 0. So this is 4x squared, and through open bracket 3 minus x is equal to 0. So therefore, x equal to 0 or x is equal to 3. So therefore, x is equal to 0 or x is equal to 3. So when x is equal to 0, we substitute the x value into this equation here to find the y value. So this means that y is equal to x times 4 times 0 minus 0, so it's 0. So therefore, 0, 0 is a stationary point. So when x is equal to 3, same thing, we just substitute into this function here to find the y value. So this is it, y equal, just replace x with 3, and that's 27. So therefore, the point 327 is a stationary point. Now we need to test it to see whether these points are maximum, minimum turning point, or point inflection. So first of all, we know y dash is 12x squared minus 4x power 3. So second derivative, give me this, and at 0, 0, I substitute into the second derivative, and it gives me 0. So therefore, 0, 0 is possible point inflection. So therefore, we need to do further testing. to see whether it is a point of inflection. So to do this, we need to substitute the left and right hand side of x value at 0 to find out whether the concavity changes. So therefore, when x is 0, we know that y double dash is 0 as well. So 0 minus 0.5 give me negative 15. 0.5 y double dash give me 9. So since concavity changes, so therefore it is a point of inflection. At 327, so we know that y double dash is equal to this, then which is equal to negative 36, and then it's less than 0. So therefore point 327 is a maximum turning point, because less than 0 is concave downward, so it's maximum turning point. Now sketch the graph. Functions clearly show the stationary points and the x and y intercepts. So first of all, to find x-intercept, we know that when y equal to 0. So this means that 4x power 3 minus x power 4 is equal to 0. To factorize it, we take our common factor, which is x power 3, and left with x minus 4 minus x is equal to 0. So therefore, x equal to 0 or x equal to 4. Now to find y-intercept is pretty easy, because when x is 0, y is equal to when x is 0, so we know that to find y-intercept, so it's equal to 0 anyway, because you can see clearly. So y equal 4 0 power 3 minus 0 power 4 is 0. So therefore 0 0 is the y-intercept and x-intercept as well. When x equals 0, it's give me y-intercept, so y equals 0 as well. Now to sketch this, so we know that the maximum turning point is 327. So 327 roughly here. So 327, and the y-intercept is 0 0, and also point of inflections. So two things. So point inflection is 0 0, and then 327 is maximum, and the y-intercept is 4 somewhere. So we just sketch it first, and then we label the intercept later. So this is a turning point here, so I just horizontal turn point inflection, sorry, we go like this, and going up, and just going down, cut here. So here somewhere, so just put bracket on this, so it's 4 here, and then this one I go back because of turning point inflections. So this is it. So this is how you graph the y equal to 4x power 3 minus x to the power 4. Thank you so much for watching my videos.